we are going to have a look at the basis of trigonometry. Now, what is trigonometry? Trigonometry is the branch of mathematics that looks into triangles, the sides, the angles, and this branch of mathematics was developed by the Greeks and we need to have a look at the word trigonometry. This is a compound made of two words. One, trigonon, and the other one was metron. These were the Greeks. And trigonon stands for triangles. And then this one is the measure. So basically, they were measuring the sides, the length of the sides of triangles, the angles, and their ratios and so forth. Now, we are going to concentrate on the basic one, that's a right angle triangle. Now, here, this is a right angle triangle, and you can call that angle alpha. And I can call this A, call that one B, call that one C. What is of most interest here is that word tri. Now, there are only three things that we work with here. The first one is a ratio. The second one is an angle. The third one is a value. Three things only. One, if you have one ratio 1:2, if the ratio of A to B is 1:2, if A gets 100 Rand, B gets 200. If A gets $4, B will get $8. So what actually happens is that A gets half of what B gets. A gets half of what B gets. Now, let's look at here, let's look at the sign of alpha. By definition, is the opposite side over the hypotenuse the side which is opposite, this angle is A, the hypotenuse is the side that is opposite a 90-degree angle and is the longest side in a right-angled triangle. Look at the second one, which is the cosine of alpha. The cosine, by definition, is adjacent over the hypotenuse and then the adjacent side to alpha is beta, is B, hypotenuse remains C. Now, the word adjacent means next to. So we're looking at the side of a triangle which is next to the angle alpha. There's your angle there. The side which is next to it is B. Now, the last one we'll have a look at is the tangent. Tangent of alpha, by definition, is opposite over adjacent. And the side that is opposite to this angle here, we know that the side is A, adjacent is B. So the tangent of theta is A over B. Now, if you have your calculator and you look for the cos of 0 degrees, the sine of 90 degrees, the cos of 45 degrees, and the tangent of 60 degrees. If you punch your calculator, the cos of, if you have to find this on your calculator, the cos of 0 degrees will be 1, the sine of 90 will be 1, and the cos of 45 will be root 2 over 2, or 1 over root 2, or 0.707, and the sine of 60 degrees, the tangent of 60 will be root 3 over 1, which is root 3, and then the sine of 60 will be root 3 over 2, or 0.866 when you punch that onto your calculator. Now, we are going to have a look at a few of examples here that put to test what you have learned. Now, here you have And then this is 90 degrees here, right angle. We have B here. We have A there. We have C there. And you have this angle theta. And then you are required to, let's see, here you have your alpha there, 1. What will be the sine? What will be the sine of alpha? The cos of alpha? The tangent of alpha? Uh, 2.1, 2.2, 2.3, the sine of theta, the cos of theta, tangent of theta. Now, in that diagram there, I'm going to do this one, do that one, do that one. You do the other 3 in your book. Now, the sine of alpha, that's my alpha. Sine by definition is opposite over hypotenuse. What is opposite to alpha is C. Hypotenuse is the longest one. The tangent is opposite over adjacent. And what is opposite alpha is C. Adjacent will be B. The last one, 2.2. This is 1.1. This is 1.3. This is 1.2. This is 1.3. The cosine of theta, cos is adjacent over hypotenuse, till we C over A. Enjoy the other 3. Now, let's look at the reciprocal functions. Now, the sine of beta is equal to opposite over hypotenuse. Now, 1 over the sine of beta is called the cosecant of beta. We abbreviate that as the cosec beta, which will be hypotenuse over the opposite side. Now, if I have 1 over the cos of theta, this is secant theta. We call it sec theta. Now we know that the cos is adjacent over hypotenuse. So that's going to be hypotenuse over adjacent. Now, we have 1 over the tangent of A one over the tangent of choose something else, 1 over the tangent of omega of ohm will be cotangent which we abbreviate as the chord. And then that the tangent is opposite over adjacent. That's going to be adjacent over opposite. Now, if A equal to 30 degrees and B is equal to 60 degrees, when you say find the sec of 30 degrees, this will be 1 over sec is the inverse of a cos. Therefore, that's going to be the cos of 30 degrees. The cos of 30 degrees is 0,866 or 1 over root 3 over 2. The answer will be 2 over root 3. Be your answer. Or you can punch your calculator there and see what you have. 1 divided by 0.866, 1.15. The whole of this gives you 1.15 in decimals. In sets, that will be your answer. Okay. We are going to have a look at we're given here. Let's look at this. You have a triangle here. this angle X here. This angle X. This is 5. This is 4. This is 3. And then the question says solve for the value of, find the value of X there. We want the value of this angle here. Now here, life is easy because we are given a number of sides. We are given a number of sides. So life is easy. Life is very easy. Now, we are going to say the sine of X, angle X, is opposite by definition, opposite over hypotenuse. This is 0.8. Now, sine of X, you say therefore, X is equal to the arc sine of 0.8 therefore X sine 0.8 will give you sine 53.13 degrees. Now, this one here is a right angle. And then if this one here is is 53.13. Therefore, this one will be 90 minus 53.13 degrees. Because this angle plus 53.15 plus 90 degrees must give us 180. The sum of the angles of a triangle add up to 180 degrees. That's what we have. Now, we're going to have a look at the second triangle. Second triangle. The second triangle will be look like this one here. In this triangle, we are given this angle here, theta. We are given this side here, 7. We are given that side there, 8. And say A, B, C forms a triangle where angle C is theta. Number 1, you find theta. Number 2, you find AC. Now, in this triangle here, we are given two sides. We are given AB and BC, and they're given 90 degrees here. So, now this side here is opposite. 8 is opposite the theta, and 7 is adjacent. Now we look at our trig ratios. Which one has opposite and adjacent? Basically, the tangent of theta is opposite by definition over adjacent. And that will be 8 over 7. And then that will be 1 comma 1,14. We have 1,14. Therefore, theta will equal to arctan 1,14 that will be second function tangent 1,14 48,74. Therefore, theta will be 47,14. Theta will be 47,14. Theta will be 47,14. Now, it's easy to find AC two ways. One, we can use Pythagoras theorem. Because triangle ABC is a right angle triangle, we can use method 1. And let's see, method 1, we say A squared is equal to AB squared plus BC squared. And this is Pythagoras theorem. AB is 8 squared. BC is 7 squared. 8 squared is 64 plus 49. That is 3. We have AC squared. Therefore, for us to get AC, we square both sides. But here we have 113. The square root of 103 is 10 point something. Let's see. 113. 10,63. Which is 10,63. Now, Let's use trig and see what we can come up with here. Now, AC, we are going to use trig now and see where will you learn this. We're going to learn here at AC, and AC is the hypotenuse. We have the opposite one, the adjacent. You can choose anyone. Let's choose the sine of theta is opposite over hypotenuse, which is AC. Rearranging that, you can have multiplied by AC on both sides. Both sides you multiply by AC, you remain with that. Meaning here, I multiply by AC, I multiply by AC, AC will drop with that there. That's what I have. But I'm looking for AC. I'm not looking for sine of theta. So I'm going to divide AC. We got our theta here as 48,74. Therefore, divide right through by the sine of theta. Sine of theta. Therefore, AC is going to be 8 divided by the sine. My theta was 48,74. Now, you say 8 divided by the sine of 48,74, get 10,64. Now look at what we had on top there. We used the theorem of Pythagoras, we ended up with that. We used trig ratios, we ended up with that. That should be fantastic. That should be fantastic for this lesson. And that will be enough and good for us for today.